A SpaceX rocket secretly intercepted an object from another star. This was the incredible story that recently went viral, painting a picture of a clandestine mission to a 7-billion-year-old comet. But is there any truth to it? The real story is a deep dive into physics, astronomy, and the immense challenges of space exploration. It reveals not a conspiracy, but a profound question about our readiness to meet the universe head-on. Let's break down the science and explore the why. What makes 3I Atlas special? First, why does an object like this even matter? Imagine holding a rock that formed billions of years before our own planet. That's the level of importance we're discussing. While the name 3I Atlas is fictional, it's a clear stand-in for real visitors like Comet C 2023, A3 Tsuchinchan Atlas. That specific comet hails from our own solar system's Oort cloud, a massive theoretical sphere of trillions of frozen objects orbiting our sun up to a light-year away. But true interstellar objects like 1I Oumuamua and 2I Borisov are far more exotic. Oumuamua, discovered by astronomer Robert Warwick in 2017, was a 400-meter-long enigma traveling at a blistering 87.3 kilometers per second relative to the Sun. 2I Borisov, spotted by Gennady Borisov in 2019, was moving at an equally impressive 32 kilometers per second. Their velocities are so high they can only be achieved by objects falling into our solar system from the vastness of interstellar space. They are in essence geological samples from other solar systems, offering us a direct look at the chemistry that forms planets around other stars. Analyzing just a few grams of this material could reveal a chemical fingerprint, a set of isotopic ratios, completely alien to our own cosmic neighborhood. The Falcon 9 connection debunked. So what about this sensational claim that a Falcon 9 chased one down? Let's look at the science and why that's physically impossible. A SpaceX Falcon 9 is an incredible machine, a workhorse that has launched over 100 times in a single year, making space access routine. But its entire design is optimized for one primary task, delivering payloads to Earth orbit. It's built to produce a massive burst of thrust from its 9 Merlin engines to overcome Earth's gravity and place a satellite like one of the 23-ton Starlink batches into a precise orbit roughly 550 kilometers up. It is fundamentally a launch vehicle, a brilliant first stage, not a deep space cruiser. The idea that it could turn on a dime and chase an object millions of kilometers away, moving at over 100,000 kilometers per hour, is a fundamental misunderstanding of its purpose. It simply does not carry the propellant, nor does it have the high-efficiency engine systems like ion drives that are designed for sustained, multi-year travel and maneuvering in deep space. It's like using a world-class sprinter to try and win the Tour de France. Both are elite athletes, but they are built for entirely different arenas. The physics of interception. To understand why interception is so hard, we need to talk about delta V. In rocketry, delta V is the ultimate currency. It measures a spacecraft's ability to change its velocity. Every maneuver costs delta V, and you only have what your fuel tank allows. Getting a satellite to low Earth orbit requires a delta V of about 9.4 kilometers per second. But to chase down an interstellar object? A detailed study for Project Lyra by the Initiative for Interstellar Studies calculated that intercepting Oumuamua would have required a delta V of more than 30 kilometers per second, and possibly as high as 70 kilometers per second depending on the timing. That is an enormous energy gap. For comparison, our fastest spacecraft, the Parker Solar Probe, will reach 192 kilometers per second, but it will take 7 years and 7 gravity assists from Venus to do so, using the Sun as a giant gravitational slingshot. It also required a Delta IV heavy rocket, far more powerful than a standard Falcon 9, just for the initial launch. The bottom line is that catching these objects isn't just a matter of pointing and shooting. It requires an almost unimaginable amount of energy planned years in advance. Alien chemistry possibilities. This is where the science gets truly exciting. What if these interstellar visitors contain a chemistry alien to our own? Any object that formed around another star would have been built from a unique nebula with a different chemical makeup. Observations of 2I Borisov, led by scientists such as Denis Bodowitz, showed it contained up to 26 times more carbon monoxide than a typical solar system comet. This points to it forming in an extremely cold, carbon-rich environment very different from our own. This leads to the ultimate question, one often raised by Harvard astronomer Avi Loeb: could these objects carry the building blocks of life but with a different twist? Life on Earth is based on left-handed amino acids, a specific molecular orientation known as chirality. What if we found right-handed versions or entirely new types of amino acids not found in the Murchison meteorite or other local samples? This discovery would provide powerful evidence for panspermia, the theory that life's ingredients are transported between star systems. It would mean the recipe for life is common in the galaxy, but that it might have different regional dialects. It would be the first concrete evidence of an alien biochemistry. 3 missed opportunities. The story of interstellar visitors so far is a story of missed chances. We've had 3 clear opportunities and we've watched each one fly by. The first was one Oumuamua, spotted on October 19, 2017. The astronomical community was in shock, nothing like it had ever been seen, but by the time Robert Warwick and his team understood its significance, it was already hurtling out of our solar system, too far and too fast to catch. Its strange shape and behavior remain a scientific puzzle. Then, on August 30, 2019, Gennady Borisov found 2 Borisov. This one was a gift because it was more comet-like, with a visible coma of gas and dust stretching nearly 160,000 kilometers wide. This allowed for spectroscopic analysis from Earth, giving us that tantalizing data about its carbon monoxide content. But again, the launch window was impossibly short. There was no spacecraft ready to go. The reality is that building, testing, and launching a deep space mission takes years, and these objects give us only a few months of warning. Each of these flybys was like an unopened letter from another star system that we could read the address on, but couldn't actually open. Future intercept technology. So, are we destined to keep missing these opportunities? The European Space Agency says no. Their solution is the Comet Interceptor mission, slated for a 2029 launch on an Ariane 6 rocket. This is a brilliant piece of long-term planning. The spacecraft will not have a pre-selected target. Instead, it will fly to the Sun-Earth Lagrange Point 2, a gravitationally stable location 1.5 million kilometers from Earth, and it will simply wait. This parking spot allows it to loiter for up to 3 years, acting as a cosmic sentry. When a suitable target is found, likely by the upcoming Vera C. Rubin Observatory in Chile, the mission will begin. That observatory, with its 8.4-meter mirror and 3.2 gigapixel camera, will scan the entire sky every few nights, making it the perfect tool for finding these fleeting visitors. Once Comet Interceptor gets its target, the main craft will deploy 2 smaller probes. Together, the 3 will fly through the comet's coma in formation, creating a 3-dimensional snapshot of its nucleus, gas, and dust with instruments like mass spectrometers and plasma imagers. This is our first real practical plan to get up close and personal. Scientific implications. So let's focus on the scientific payoff here because honestly it would be enormous. Intercepting one of these objects would move us from theory to fact on some of humanity's biggest questions. First, by analyzing its composition and isotopic ratios, the unique signature of neutrons in its atoms, we could get a definitive fingerprint of another solar system's planetary nursery. Different stars forge elements in slightly different ways, so this would be like a birth certificate for the object's parent star. Second, as scientists like Avi Loeb have pointed out, we should be prepared for the unexpected. A detailed chemical analysis could reveal biosignatures or even technosignatures that are completely unanticipated. Most profoundly, finding unique organic compounds or amino acids would provide the first direct evidence for panspermia, the idea that the ingredients for life are common throughout the cosmos. This isn't just about rocks and ice, it's about understanding our own origins, the potential for life elsewhere, and our ultimate place in the universe. Trajectory analysis and mysteries. So how do we know for certain they are from interstellar space? The answer is in the geometry of their orbits. Everything in our solar system follows a closed elliptical path. These visitors, however, are on a hyperbolic path. It's a one-way ticket. They fly in, loop around the sun, and fly back out, never to return. Their extreme speed prevents the sun's gravity from capturing them. But the trajectory of Oumuamua held a deeper mystery. A team led by Marco Micheli of the ESA confirmed it had a slight non-gravitational acceleration. It was being pushed by something other than gravity, at about 1.5 millimeters per second squared. The leading scientific hypothesis, championed by astronomers like Jennifer Bergner, is that this was caused by the outgassing of trapped hydrogen ice as it was warmed by the sun, creating an invisible, rocket-like effect. But because this couldn't be visually confirmed, the puzzle remains, fueling all sorts of speculation. This single data point shows how little we know and why getting close-up data is so critical. The official facts. To ground this discussion in reality, let's review the verified data for Comet C 2023 A3 Tsuchinshan Atlas. It was first imaged on January 9, 2023, and officially confirmed on February 22, 2023. The Atlas survey that helped find it is a network of telescopes designed specifically to find near-Earth objects. This comet is from our Oort cloud, not another star, with an orbital inclination of 139 degrees. Its perihelion, or closest approach to the Sun, was on September 27, 2024, at a distance of about 58 million kilometers. It passed closest to Earth on October 12, 2024, at a safe distance of 71 million kilometers, reaching a peak brightness that made it visible with binoculars. Its nucleus is estimated to be several kilometers in diameter, and to be absolutely clear, no spacecraft, Falcon 9 or otherwise, has intercepted it. The viral story was an exciting piece of fiction, but the real comet and the real science are arguably even more compelling. The bigger picture. The false Falcon 9 story, while incorrect, forces us to look at a larger truth. We are at a turning point in human history. For the first time, we possess the technology to not only see these interstellar messengers, but to actively chase them. With new telescopes like the Vera C. Rubin Observatory coming online, its director, Zeljko Ivazic, has predicted we may soon spot dozens of these objects every year. The question is no longer one of capability, but of will and preparation. Do we invest in a permanent rapid response intercept program? Missions like Comet Interceptor are the first step, but a dedicated program would ensure we never miss another opportunity. This is a strategic decision about our future as a spacefaring civilization, akin to the commitment made during the Apollo era. The choices we make in the next decade will determine whether we become active explorers of the galaxy or remain passive observers, watching the biggest discoveries fly right by us. So, while a Falcon 9 didn't actually intercept an alien comet, the underlying science is what truly matters. We now know our solar system is visited by objects from other stars, carrying clues to some of the universe's biggest mysteries. The next one is already on its way. What do you think humanity should do to be ready for it? Let us know your thoughts in the comments. Don't forget to like, subscribe, and hit the bell icon to join us as we continue to explore the Psi and Why. Thanks for watching.